right, so hopefully you took a minute to try to fill out this table, or maybe you waited for me. But for this next section over here, this is just a way to kind of drill multiple problems at once using a table. And what we're saying is we have a 45, 45, 90 triangle as what's given up here. We drew it on the side. And if we give you the legs, the question is, what is the hypotenuse? And we can reverse it. And here's 4 problems. If we give you the hypotenuse, how do we reverse it and get the legs? And again, it's just I'm getting multiple practice. All right, so we don't need to label the problem, but it's just understanding visually what's happening. So we're saying if both of these sides are, or if one side is a 5, what is the other leg? And then what is the hypotenuse? All right, so if one leg is a 5, we know the other one is a 5. And I'll do the 10 as well. If one leg is a 10, we know the other one is a 10. All right, and how do you get the hypotenuse? You simply take the leg and you multiply it by the square root of 2 for each one of these. All right, so what I'm going to do over here is just write that little rule down. From leg to getting the hypotenuse, you will multiply by the square root of 2. And then for all these, we're going to reverse it. Now we are going to be given the hypotenuse and we want to know what the legs are. And when you reverse it, you're getting smaller. So you're going to divide by the square root of 2. All right, so we'll just quickly do these. If you haven't done it yet, you take the hypotenuse, 9 root 2, and divide it by the square root of 2. The square roots cancel, leaving you with 9. So if one leg is 9, guess what? So is the other. Now let's change to 12 root 6 as the hypotenuse. What did you do? You divided it by the square root of 2. And that quick drill that we did on the other side, remember that? Don't rationalize it. Go ahead and simplify those square roots, and you end up with 12 times the square root of 3. And this is 12 root 3 as well. All right, so if you would have rationalized it, you would have had a little mess, but as long as you did your algebra right, it would simplify down to 12 root 3. The next one, if you are given the hypotenuse as a 12, let's go ahead and divide by the square root of 2, and then rationalizing it, you get 12 root 2, all divided by 2, simplifies down to 6 root 2. And if one leg is 6 root 2, so is the other. One more. If the hypotenuse is 15, you're going to go ahead and divide it by the square root of 2. Rationalizing that, you get 15 root 2 all over 2. And then ask yourself, can that be simplified down? All right, and we don't want decimal answers. Just leave it as a simplified fraction. 15 is not divisible by 2. So that would be your final simplified answer. And there you have it. Alrighty, so check your work on that. Hopefully you were successful. And now the fun stuff, getting into some application problems. All right, so some application problems, and the one that you will always see, or typically see, a common one would be a square. All right, so a square, when you draw the diagonal of a square, because if you notice both of these are referencing diagonals. All right, so I have this one, and I'm just going to go ahead and put all the markings on it that represent a square. Remember, by definition of a square, all 4 sides are equal, and all angles are 90 degrees. All 90 degrees there. So we're referencing, if you read the problem, you have diagonals. Okay. All right, so the given information that this triangle has a side length of 3 root 5. So let's go ahead and put it at least one spot. You don't have to put it on all of the sides because we do know they're already marked equal. So there you have a side length. All right, and then we have, they want to know what is the length of that diagonal, what is the perimeter, and then what is the area of the square itself. All right, so let's examine this. What you have here from all of the markings, I want you to focus on just half of the square. See this right here? This right here is an isosceles right triangle. Well, right away you should be thinking, ding, ding, ding. That is a 45, 45, 90. Isosceles right triangles will always be 45, 45, 90. So now what we just learned is the ratio of the legs to the hypotenuse. If we know the leg length of a right triangle, that is an isosceles right triangle, then you simply multiply by the square root of 2 to get the diagonal. All right, so let's get the diagonal. I'm going to use D for diagonal. All right, so the diagonal is the hypotenuse, keep in mind, of that triangle. All right, we can write over here, hypotenuse. Okay, and to get it, you're going to simply take the leg, 3 root 5, and we're going to multiply it by the square root of 2. And that yields 3 root 10. Now, I don't have any units here, so we're just going to label it as units. Okay. The next one, perimeter. Perimeter, recall, is the distance around the figure. So you can either say 3 root 5 plus 3 root 5 plus 3 root 5, add all 4 of them up. Or you can say, well, there's 4 of them. Each of them has a length of 3 root 5, and multiplying only the numbers on the outside together will give you the sum of all 4. And there you have the perimeter. The area, now keep in mind, a square is actually a rectangle as well, and the area formula is your base times your height, your length times your width, but the sides are equal. So we make this easier on ourselves by thinking about it as it is just simply side squared. All right, so if you know that one of the sides is 3 root 5, when you square it, that'll give you the area. All right, and we know quick ways to multiply this. You square the first one, you get 9. Root 5 times root 5 is 5, and that simplifies down to 45 units. Dun, dun, dun. And don't forget to square it. And there you have your area. All right, so we have our diagonal, perimeter, and area. This next problem is really similar. All right, so once again, we are describing a square. So go ahead, get set up. Always, I require you. That's kind of an ugly square. We're going to undo that square. Let's start over. That's a little better. All right, we're going to mark those equal. We're going to put little 90s in there. All right. So it says a square has a diagonal. All right, let's draw it. Remember what a diagonal is. We talked about these in the past, but a diagonal connects every other vertex. It goes to the interior. And there you have it. There you have. We're just going to draw one. Don't draw both. All right, just one is sufficient. All right, so a square has a diagonal, and it tells us the length. All right, so this has a length. Oh, we have a unit, 12 inches. And they want to know what is the side. So why don't we call that X, and we'll put X in the figure. And we want to know what is the perimeter, the side, and the area. Okay, so again, we have a 45, 45, 90 triangle. There's a 45, there's a 45, there's your 90. You have the hypotenuse, so reversal, get the side length. All right, so to get the side is the leg, and you find the leg, and I'll put in parentheses, it is the leg. You're going to take the hypotenuse, which is the diagonal of that 45, 45, 90, and you're going to reverse the process and divide by the square root of 2. All right, so the hypotenuse is 12 divided by the square root of 2. Let's rationalize that. And think about it, is that simplified? And it is not. So we're going to rewrite this. 12 divided by 2 is 6, and you get 6 root 2. And we do have inches. So each of these sides is 6 root 2. And you can write them all down if you want, all the way around, but you don't need to. The perimeter is 4 times 6 root 2. 4 times 6 is 24. And don't forget inches. Lastly, what is the area? The area is the side squared. And we get 6 root 2 to the second power. And then that simplifies down to 6 squared is 36. Root 2 times root 2 is 2. for a grand total of 72 inches squared for the area. Alrighty, my friends, there we have it. All right, so we have the side length, the perimeter, and finally the area of that square. All right, so squares, again, is always going to be a red flag that you're going to be working with 45, 45, 90 triangles. They're very common. And do memorize this relationship. It's not going away. You're going to see it, the special right triangle in Algebra 2. You're going to see it in pre-calculus and here on forward for probably just about any math class that you have down the road. All right, so it's time to just get this down. It'll make your life easier down the road. All right, well, thank you for joining me here today. Here's your full notes. If you missed any of the other segments, hopefully you're able to access the previous recordings on how I arrived at all of these. Thank you and have a good day.